What's up, guys? Joe Gaming. Joe Gaming. Today, there is no Matt Conk here because rest in peace, Matt Conk. I'm sure the next Joe Gaming there will be the Matt Conk here, but for now, there's no Matt Conk here. And today, we're gonna be doing an integral. Because why not? So, here's the integral. Okay, whatever. Anyway, so let me switch the song. I don't know what the song is, but anyway. Alright, so to start this integral, let's see. So, I want you to notice something. And it's that you're gonna be like, how are we gonna do anything about? You're gonna notice the tan square, you're gonna notice this, you're gonna notice that. And you're probably like, what should I do? Well, the first thing that should come to mind is u sub. But the thing is if you try any u sub that you can think of right now, you're not gonna get anywhere with just what you're given, face value. Alright? So before we do any u sub, we're gonna have to do some transformations in order to sub out some stuff. So as we know, u sub, the purpose of it is either to substitute it for an easier dummy variable or to cancel out terms that you don't want. And the only way I can see using u sub at this moment is to simplify this or this. Now, the fact that says 1 plus tan squared and it's to the e suggests to me that the u sub should be tan squared. But that's just a hunch, okay? Now, obviously, if it doesn't work out, we're gonna try a different method, but let's just assume this is gonna work for now. But first, before we use sub, we're gonna have to find this. We're gonna have to turn this into a bunch of variables that have tangent in it, okay? So, sin 4x. If you don't know, sin a plus b equals cos a times sin b plus cos a and cos b sin a, alright? But since it's 4x, that would mean that a and b are both 2x, so we can write this as 2 times cosine 2x times sin x. 2 times 2. If you don't know how I got to here, you're gonna have to review some trig identities. But like I said, sin a plus b equals cos a times sin b plus sin b times cos a, or whatever it was. Just know that a and b are the same thing, which are 2x. And since they're the same thing, just 2, yeah, you get it. I don't want to write it down, but yeah. Now, from here, you still have to realize that we're not going to use sub just yet, because 2x versus x in here. If we were to use sub, this 2x is pretty troublesome, to say the least. So we're still going to have to simplify to get only 1x in these cosine sine x, whatever. Now, here's the cool part. Hold on. So, cosine 2x, a lot of people may know what that is. It's, well, cosine a plus b equals cosine a times cosine b minus sin a times sin b, right? Well, if they're the same values, if they're both x, it's just cosine squared minus sine squared, right? I'm gonna just write c squared for cosine squared, I'm not gonna write cx for cosine x, okay? Minus s squared x. This means sine x, I'm not gonna write the whole thing down, right? And notice that now it's finally at 1x value, just like this tangent. So we're getting somewhere close, and we're really close if you consider something. So, how can we get tangent from here? Well, if you realize that if you factor out cosine squared from this term and this term, you would get 1 minus tangent squared x. T squared x. Right? Times cosine squared x. That's why when you factor out cosine squared x from these two terms, it turns to 1, this turns to tangent squared x. And we still, even though there's a tangent here and that's nice and all, I still want to convert this term into at least a constant or a tangent. Alright? And if you didn't know, let's go with a different so if you didn't know, c squared plus c sine squared equals 1, right? Now, here's the cool part. If you do exactly what I did for this, and factor out cosine squared, you get cosine squared x equals 1 over Alright, got funk on. You get 1 over 1 plus tangent squared. I hope you can see how I got to that conclusion without having to show you all the steps. Just factor out cosine squared x and you get 1 plus tangent squared x times cosine squared x equals 1 and you divide it. You just get cosine squared x equals whatever, yeah? If you can see that then, knowing that, if you sub for that, not you sub in cosine squared x for this cosine squared over here, you would get, let's just say cotangent x, cosecant, cosine 2x equals 1 minus t squared over 1 plus t squared to tangent squared x. Okay? See that? If you can follow through this entire method, then I think you can follow with the rest of the video. So, now that we know what cosine 2x equals, we can sub in for this. But we still have this 2x in whatever in here. The 2x still remains, and sine is not tangent. So what do we do? Who knows?
Check.
Well, I'll tell you what we're going to do. The same way we derived what cosine 2x could possibly equal to and what cosine squared x could possibly equal to. Let's do the same for sin 2x. So I'm gonna try and erase all this. Alright, so let's just write over here to remember c2x equals 1 minus t squared x. Alright, what does sine 2x equal? Well, if you follow the same pattern we did to expand sin 4x, you can expand sin 2x. So sin 2x equals 2 times cos x times sine x. Now the x's are the same as this tangent x. And same reasoning, same methods as where we got cosine 2x. Factor out cosine squared 2x, just squared x. And you're like asking, there isn't a cosine squared x. Well, factoring is not about getting rid of terms you already have or simplifying that. It's about dividing and multiplying. The a times 1 over a. You know what I'm saying? They cancel out into 1, so you can do whatever you want as long as they cancel out. So that's basically factoring. So I'm going to factor out cosine squared x to get 2 times, well, cosine squared x divided by this term. Well, this cancels out, so it's just sine x over cosine x, right? Because the square just decreases by 1, and this one is just turns to 1. We get 2 times tangent x. But then remember, it's all multiplied by c squared x. But as we remember what we got from last time, secant squared x is equal to 1 over 1 plus tan squared x. So now we know what sin 2x equals in terms of tangent, and what cosine 2x equals in terms of tangent. We can just simplify, we just put all the things back in, and we finally get the equation integral of 2 tangent x 1 plus tangent squared x times 1 minus tangent squared x. He's carrying no girth. It's very thin, bright and red, like my dog's. Times e to the tangent squared x. So we did it, guys. We finally turned everything to tangents. And now we can finally use up. Alright. As we know, if we use up in an integral, we're gonna have to change out the dx. And let's see what dx is in terms of the u. So dx what's the derivative of tangent squared? Well, it's 2 times. Oh wait, I forgot the 2 here. My bad, guys. 2 times dx is 2 times tangent x scx squared. Okay, if you don't know how I got that as a derivative, then you're probably cooked it. Okay. Anyways. And that's equal to du. And now you're like, wait. We have a secant squared now. How are we gonna cancel anything out? Well, if you didn't know, whatever I wrote, remember the identity, the cosine squared x plus sine squared x equal 1? Well, similarly, if you just divide everything by cosine squared x, you'd get 1 plus tangent squared x equals secant squared x, so this is where the tangent comes right here. So, let's get dx 2 times tangent x times 1 plus tangent squared x. And if you didn't know, since u equals tangent squared x, let's just sub in 1 plus u equals du. And the reason why I'm not going to simplify this 2 tangent x to square root u is it's going to cancel out anyway, so just watch. Hold on. So, if you realize, 2 times tangent x is also right here in this term, so we can just get rid of that. Get rid of that too. The song is kind of crazy. And now we got 1 plus u. Now, the only 1 plus u, after turning everything into a u, is these 2 terms. This is 1 plus u and that's 1 plus u. So, it would actually be, the new equation would be something like this. Oh, oops, I need to make it u, and then 1 plus u cubed, because of this 1 plus u, we gotta divide it on this side, so now there's 1 plus u cubed instead of squared now, and then times e to the u. And now you're like, yeah, this is definitely cooked, bro. What do you do here? And it looks a lot more simpler than last time, than whatever that was. So we're getting a little bit closer, I guess you could say. What is this? Oh. This gave me AIDS, dude. Alright, guys, so, anyways. So, from here, you'll notice that 1 minus u looks, you can feel a feeling that you should cancel this out, right? Well, before you do that, how about we factor out negative, the negative right here, so then it would be negative 2 on the outside plus minus 1. And all we have to do from here is do plus 1 minus 1, right? So plus 1 minus 1, so it's still equal. This would just equal minus 2, and then bracket. Well, if we just take in only this 1 plus u right here, u plus 1, we can cancel it like that. And what we get is the integral of e to the u over 1 plus u squared. And next would be minus, well, all that's left after we simplify that is that double negative 1s turn to negative 2. So it would be minus 2 integral of e to the u over 1 plus u cubed. Now, this does get a little bit more simpler than the previous integral, or the initial. But you're like, oh, what do you do here? Well, the only thing to do here, obvious thing to do, is to integral by parts. And first one I want to do is probably this one, right? That is be sigma, if I had to say so myself, right? So, with all this, I'm going to try to erase all this. Bye. Let's get rid of all that. Oh, can you? Anyways, we're going to call this, I for now, right? And so therefore, I is going to equal negative 2 times. We're almost done. Just do integral by parts of e to u 1 plus u squared. Remember Layats, just remember Layats, and what we know from Layats is that exponential functions should be the last thing you turn u equal, and algebraic is before it, so let's do u equals, actually I probably should call u, but special u equals 1 over 1 plus u squared. And the u, simply put, is equal to negative 2, 1 plus u cubed. The u, normal u, right? And we got dv equals e to u du, and then v equals e to u. And so plug in uv, so it's 1, alright, so it's just e to the u, follows minus integral of v du, v is e to the u, du equals negative 2, so that negative 2 is going to turn to plus 2, integral e to the u, 1 plus u cubed du, and that's equal to this integral right here. And if you realize, since this is all negative 2, and then the integral, let's see, so we're going to sub in this integral right here for what we expanded it on, and then minus 2 integral, well, I think you can get the idea, e to u plus u cubed plus 2 minus 2, they cancel out, okay? They really cancel out. Alright, I'm not going to write it down, they cancel out, okay? So, all there's left is negative 2 e to the u plus e equals I. And you know what I equals? I equals this, and if you plug in back u, u equals negative 2 e tan squared. I'm not writing tan squared. 1 or 2 plus, yeah, 1 plus tan squared x. And even though, technically speaking, that we didn't integrate anything specifically, we still put the plus c because that's an antiderivative and you just never know about the constant, okay? So because I is an integral value, there must be a plus c at the end of the answer, so that's why there's a plus c, even though there was technically no integral that we got this answer from. We just cancelled 2 integrals. Anyway, so that's your answer to this. Negative 2 e to tangent x squared x over 1 plus tan squared x. Was there an easier way to do this? Probably, but who knows? Because to me, the actual answer was negative 2 e to tangent squared x times cosecant squared x, right? And someone could have saw that coming. Who would have known? Because did you know the derivative of cosine squared x is actually sine 2x, or at least negative sine 2x? So someone could have saw that coming, low-key, no lie. Someone could have easily, not gonna lie, but whatever. That's the answer. I'm not surprised that it is the answer, because just look at it. Anyways, there you go, that's the end. Goodbye.